Good morning, everyone, and welcome to our presentation. First of all, let's thank you for taking time to watch this video. Let me introduce myself. My name is Thanakorn Williams, and I'm here with my team members. They are Pongsakorn Thonglit, Pongsakorn Vasanapakon Kun, Punyaphat Rung Soviet, and the last one, Thanat Kunalong. We are third-year students from King Mongkut Institute of Technology Lat Krabang, or KMITL in Bangkok. Why we need to know about mothers? Nowadays, we use in our daily routine, or in other words, we can say that mothers have been parts of our life. The devices which have mothers can make relief easier. For example, refrigerators, vacuum cleaners, air conditioners, automatic car windows, and multitudes of other appliances and devices all use electric motors to convert electrical energy into useful mechanical energy. Now that we know that motors are important to humans and would be useless if we didn't know how to start using this. That's why we're here to discuss what kind of starter motors is the best between start without start and direct on-ride start or DOL. This presentation is structured as follows. First, we will give you an overview of theory background. Second, we will tell you about methodology. Third, finding, and finally, implication. Now that I have given you an overview of theory background.
Hello everyone, welcome to my part, the theory background. As you see in the slide, in this part, I'm going to talk about the hypothesis, the star delta starting, the leg online starting, and experimental equipment. In the hypothesis about this experiment, first one is when you start a motor with a direct online starting, it will spend time less than star delta starting. The second is when you start a motor with a direct online starting, it would have starting torque and starting current higher than the star delta starting. In a star delta starting, the first period, the motor is connected to the star connection, and then once the motor has reached the required speed, the motor is connected to the delta connection. In direct online starting, the motor is connected directly to the three-phase supply. By the way, in this connection, no harm is done to the motor because it contains a protection device like fuse. The last topic is the experimental equipment. The first one that we use is the push button switch. The push button switch is we use it to control the control circuit, and it's working by press by hand, and it has two types. The first type is the memory open, and the second type is the memory closed. Next is a relay. A relay is a switch that uses magnetic power help to cut or connect the control circuit. In general, we have many types of the relay, but in this experimental, we use a timer and overload relay, as the slide shows. And the last is a magnetic contactor. The component, the construction, and the operation same as a relay, but it's bigger, and we use it in the main circuit. And next, I'm going to pass you to Pongsakorn, who is going to talk about the methodology.
Welcome to methodology part. The connector connection is divided into many forms. such as direct starting, star delta starting. Inside the motor circuit is divided into two types, power circuit and control circuit as shown in figure 1.2 and 1.1 respectively. So let's talk about how does the three-phase motor work on direct starting. The first, you need to know that S is switch, H is light, K is contactor. To start the motor of control circuit, we place switch on at S2. It makes contactor K1 lamp H1 work. Then this K1 switch is closed because there is power supply to contactor K1 all the time until the stop button S1 is placed. In power circuit, after the contactor K1 works, switch K1 is closed because the motor works as shown in figure 1.1. And next, let's talk about how does three-phase motor work on star delta starting. Star delta starting works similar to direct motor starting, but star delta works in two ways, both star working and delta working. If contactor K1 works with contactor K2, it works star, and if contactor K1 works with contactor K3, it works delta. In control circuit, we place switch on at S2. It makes contactor K1 lamp H1 contactor K2 work. It is star working, and wait for 5 seconds, then timing delay contactor inverse. And now, contactor K1 is working with contactor K3. It's delta working. Next, we do three types of experiment: no load, regular load, and heavy load. I will pass you over to Punjapat, who is going to talk about finding.
From the experiment to find the starting time of the motor rotation, the result will be added in the table. In the first column, it shows the starting time of the direct or line starter, and in the second column, it shows the starting time of the star delta starter. By both of them are attaching all T type of load. As the table indicates that the average starting time of direct or line starter is less than the average starting time of the star delta starter. And we can also analyze to find current start and torque start by using the formula in the next slide. From this formula, it can infer that current and torque are inverse to time, or it means if current and torque are increased, time will decrease. For direct or line starter, it takes a little time to start motor. That it means it had a lot of current and torque start over than the star delta starter type. From hypothesis, we have the graph to show about the working of the both starter. For the graph, point 1 is the starting point, point 2 is the starting time of the direct or line starter, and point 3 is the starting time of the star delta starter. For modern line, direct or line starter, it has a lot of current from the starting point, and it takes a little time to start motor. And from pink line, star delta starter, it has a low current from the starting point, and it uses a lot of time to start motor. Next, I will pass you over to Thanat, who is going to talk about implication.
Welcome to implication part. From the finding, it found that the two types of motor starter have different in advantage and disadvantage. The advantage of direct or line starter include: first, simple and more economical starter. Second, more comfortable to design, operate, and control. Third, provide nearly full starting torque at starting. And the last one, easy to understand and maintain. The disadvantage of direct or line starter includes: first, high starting current. Second, direct or line starter cause a significant dip in voltage, hence suitable only for small motor. Third, direct or line starter reduce the lifespan of the machine. And the last one, unnecessarily high starting torque. The application of direct or line starter are primarily motor, where a high inrush current does not cause excessive voltage drop in the supply circuit. Direct online starters are commonly used to start small water pump, conveyor belt, fan, and compressor. The advantage of a star-delta starter includes reduced starting current to prevent a motor, and easy to maintain. The disadvantage of a star-delta starter includes more expensive and more complex circuit than direct online starter, so it's easier to error. As discussed in the above advantage and disadvantage, a star-delta starter is most suited to application where the required starting current is low and where the line current draw must be at a minimum value. The star-delta starter is not suitable for application where high starting torque delivery is required. For this application, a direct online starter should be used instead. Next, I will pass you over to Thanakorn, who will conclude the presentation.
Well, that brings us to the end of our presentation. In conclusion, I'd like to briefly summarize the main points that group has covered. In beginning, we've given you an overview of electric circuit and experimental equipment that we use for calculating. After that, we've explained about methodology of calculating program. We've also given you the finding of the case study experiment. And finally, we've discussed the implication that we get from experiment. We hope you find our presentation interesting. If you have a question, comment down below, and thank you for watching.